Hi, I'm Andy Henry with the NASA Science Activation AEROKATS and ROVER Education Network, or AREN project, a GLOBE partner. We introduce learners of all ages to novel NASA technologies, including instrumented kite-borne platforms called AEROPODs, to conduct local-scale remote sensing missions and collect remote in-situ measurements of atmospheric phenomena, as well as instrumented remote-controlled watercraft called ROVERs to conduct explorations of water bodies remote from shore. We're quite excited about the GLOBE Urban Heat Island Effect campaign starting this month and led by Dr. Kevin Chakowski with GLOBE Mission Earth, another NASA Science Activation project. Part of that excitement is because we're testing a new platform we are calling TerraRover, a remote-controlled terrestrial vehicle that can carry instruments for investigating different surface phenomena, and the first set of sensors we've designed for the TerraRover is what we're calling the Urban Heat Island Instrumentation Package. This package integrates an Arduino Leonardo board, an infrared temperature sensor, an air temperature and relative humidity sensor, and a GPS sensor and data logger. This will measure the temperature of the ground surface and the temperature and relative humidity level of the air above it as the TerraRover passes over. The GPS and data logger will capture the location of each data point and log the data. The output is a text file with all of the data points presented in a CSV format. This will allow students to easily map the data and look at the effects of solar heating on a large variety of surfaces. The data cannot at present be integrated into the GLOBE database as part of the actual campaign, but we think it would be quite useful in concert with the data collected manually for the campaign in informing student research projects. We hope to have our first group of students using this new platform during the Spring 2021 campaign. Here's a quick demo of how a couple of online software tools can be used to visualize the data. The first is ArcGIS Online. ArcGIS Online is free to schools, but it does require a subscription. I'll start out by going to my account and selecting the Content tab. Next, I will select Add Item from your computer and browse to my CSV file. I'll add some tags to the layer to help for searching. And I'll confirm that the longitude and latitude fields in my data are being used for the location fields. When I am satisfied, I'll go ahead and click Add Item. The CSV file is now added to my content as a layer in ArcGIS Online. The software will take me to the Item Details page where I can edit its metadata. This helps people who might use the data to know where it came from and provides additional information about the data. Metadata is important for verifying that you are using data from a reliable source. I'll click Open in Map Viewer to add the layer to a new map. The layer opens in a default map. I hit the Home button so that all of my data is visible. I will also change the base map to imagery so that I can see the data points over an image of the land cover. By default, the map is chosen to display the infrared temperature field in my data. That's fine, but I'm going to change the way the layer symbols appear by changing from symbolic size to a color ramp. I will choose a color ramp that I feel is appropriate to show my temperature data, yellow to red. The symbology will change to a color ramp. There are options to classify the data, but I'll accept the defaults. Lastly, I'll change the transparency so that my points show up better against the imagery. Then I will click OK, then Done. Now the layer appears in the map the way I want. I'll rename the layer Surface Temperature because that's what the IR temperature sensor is measuring. If I click on any point in the map, the data from the CSV file about that point appears in a pop-up, and I can look for any obvious visual correlations between surface types and surface temperature. The layer file also contains data about air temperature and relative humidity. I want to show these too, so I'll create copies of the surface temperature layer and rename each layer, selecting the corresponding field to symbolize, and I'll repeat the process we just did. I'm skipping showing the steps again for time. When I'm done, I can grab the layers in the menu and rearrange their order how I like. I can also look to see if there's any obvious correlation between surface and air temperature or relative humidity. Next, I'm going to use a simple filter tool to show only the points where the surface temperature is above 16 degrees centigrade. I'll turn off the other layers to see my data more clearly. Are there any obvious patterns? There are many other analysis tools built into ArcGIS Online to help you explore your data further. For now, though, I want to show another tool that we can use with the Terra rover data, CODAP from the Concord Consortium. CODAP is also free and it's easy to use. I'll start by creating a new document. I'll choose Import from the menu and drag the CSV file from my computer into the bin. My data appears in the table. I'll expand it so that I can see more of it. Next, I'll click on the map icon in the menu bar to add a map to the window. The map defaulted to showing data from the date field. I'll drag the column heading for IR temp from the table to the map. Now the map will display the surface temperature and a color ramp will be used to show values. I'll change the ramp to a different color. I'll add a chart by clicking the chart icon in the menu bar. I can reposition it how I like. I will click on the Y-axis title and choose IR temp for that axis. And I will choose time for the X-axis. As with ArcGIS Online, CODAP has more analysis tools built in to explore your data. This is just a start. So that is a quick look at using a couple of powerful data tools to explore data from a new instrument platform from the AREN project. Ultimately, we'd like to make this platform available as a kit, allowing students to use either instrument packages that have been designed by the AREN team or engineering their own instrument packages to investigate phenomena that they identify for their own research. Look for more information about Terra rover in the spring of 2021 on the Globe website at this address. Thanks, everyone.